is Destiny Herrera, and I'm accompanied by my partners, VNA, Travis, and Andrew. I'm displaying an overall preview of our project and going to explain the purpose and general information of our chosen datasets before my partners jump in and explain the MATLAB code. The challenge, develop carbon sequestration methods, developed because of enormous carbon dioxide emissions from industries, factories, and vehicles, and has been evoked by the NAE Engineering Committee to find a solution to prevent carbon dioxide from dissolving in the atmosphere. Therefore, as engineers, we are supposed to resolve problems for the well-being of mankind. It becomes the obligation of engineers to invent methods for sequestrating carbon dioxide and refrain it from entering the atmosphere and ultimately leading to global warming. The goal of the project is to develop a program on MATLAB by code which can explore hourly carbon emissions in U.S., daily uses which contribute to carbon emission, individual state contribution to sequestrate carbon dioxide, taking multiple factors into account. The user will have an innumerable options to select, and outputted data will be completely based upon the user's selection. That being said, the code can be very complicated and vast, but the user will have a clear idea of the problems that make carbon dioxide an issue. Major problems that need to be fixed before trying to sequestrate carbon dioxide, and most importantly, the user's concerns will be cleared, pertinent to the data. The first data set we use is carbon emission by daily uses. It has an enormous information about the emission of carbon dioxide with respect to daily uses in different countries. The second data set we chose to use was the hourly carbon emission in the U.S. This data set gives a comparison of carbon dioxide to nitrous and sulfur oxides released on an hourly basis in each month. The third data set we chose to use was the environmental data of each state. This data allows the user to understand the complications of carbon sequestration. It is restricted to the U.S. and has really good information about tree coverage in each state, forests, land, government spending to sequestrate carbon, and amount of carbon sequestrated.
The code starts engaging with the user with the menu option, and this is the menu option. As you can see, the four options basically provide the user with an opportunity to explore emissions of carbon dioxide in various countries in different sectors and explore environmental data in the United States, annual carbon dioxide emission in different countries, and the cost to sequestrate carbon with several user inputs. As the user selects the first option, which is this one, several countries will be shown in the menu, and as the user selects the countries, so these are the countries. It's Italy, Germany, Europe, Denmark, and Belgium. And as the user selects the countries, a menu will be popped up showing various sectors. So for example, if I pop up Germany, this is a long list of menu which pops up several sectors relating to various fields starting from industry till waste. Then exiting out of this, when the user tries to select the third option, which is the annual carbon dioxide production by various countries, again a list of countries will be popped up. For example, like North America and Canada and Mexico. So suppose if I click North America, a graph will be, so it will be asking me the year to compare the annual carbon emission. Suppose if I have 2003, the year 2003, the data is not available, so even data validations are included. So the data is only available from 2005 to 2009. And if I have 2006, then this is my graph for annual carbon emission in North America from 2005 till 2009. So this is how the algorithm works, and there are many data validations. So for example, the user cannot exit out of the menu, and I'm showing that, just a second. So suppose if this is the menu and the user has to select one of these and he cannot simply exit. If he tries to do so, it will keep asking the user until and unless he selects an option. So here are the 4 options, and this is the method or algorithm. Thank you.
Alright, I'm gonna demonstrate a little bit of how the code works and its capabilities. So this code, first of all, it has a bunch of different CO2 emission data for all these different places. And so when I start the code, I run it, it's gonna give me 4 different options I want to explore in the CO2 emissions of all the data we got. So the first one is CO2 in different and the daily uses in different countries. So when I click on that, they give me these 5 countries I get to choose, and I'm gonna choose Europe just for example. And then now they have all these different environment factors. That you can choose from to explore. And so I'm gonna choose chemicals. And so the chemicals, and now it's gonna answer. It's gonna ask for me to enter a year for the data in between a certain range. And the cool thing about our code is that it has a conditional statement and a while loop, to which if I don't enter the correct range, it's gonna keep repeating and asking me. So for instance, if I put 1850, it's gonna give me a warning, tell me to enter the correct one. If I say it again, it's still a while loop until I put in the correct data. So now I'm gonna put in the correct data, 1991, and now in the command line, as you can see, it's gonna give me all the information about that specific country and all the CO2 emissions for that specific place. As you can see, it says 1991, the year entered 82.9 million tons of carbon dioxide was released in the chemical sectors and so forth. And so now, at the end of the command window, it's going to ask me if I want to repeat, and if I want to compare it with another country. And so click yes. If I type in yes, it's going to do that. So I can choose which country I want to compare this with for that factor and for that country for daily CO2 emissions. So I'm going to choose Belgium. And as you can see, it brings up a graph that displays the chemical sectors for Europe and Belgium versus 2 years between Belgium and Europe. And so that's the graph. And I can either restart it or just end it. So that's meaning that that's the only data I want. But in this case, I want to restart it to get the data. So let's go explore the second option, which is environmental data in the U.S. So if I click on that, it's going to ask me if I want to explore environmental data in certain cities or explore the environmental factors themselves. And so I'm going to do different cities first. So as you can see, there's a list of different cities, and I'm going to choose on New Jersey. When I explore New Jersey, it's going to give me all these environmental factors that contribute to CO2 emissions. Like, for instance, it's going to tell me how much land there is, how much land area, and it's going to say how much money they spend sequestrating carbon, the money spent for population uptake and whatnot, and yeah, so forth. So now it's going to ask me the same thing as the first option did, if I want to restart it. If I don't, I'm going to say yes. So now let's explore the second option, explore environmental factors. So there's a bunch of different environmental factors that I can explore. Let's do how much carbon sequestration they do in tons. Let's do millions per year, actually, because I want to see how much money they spend. And so now, this is basically telling you how much money that specific city spends sequestrating carbon, meaning how much they're spending to try to get rid of the carbon that they're emitting from the factories and whatnot. And so it tells you that the money they spent for a population of this 0.196 million, which is a good value. All right, and it's gonna, as the last answer, I can either restart it or no thanks, but I'm gonna restart it. So let's choose the third option, annual carbon dioxide production by various countries. So if I choose that one, it's gonna show me the CO2 emissions for a certain country annually, yearly, basically. So I'm gonna choose Greenland. And so it's kind of like the same thing for the first option you choose. They have a certain range of years for data, and so same thing with the if and conditional statements. If I enter the wrong range, it's gonna tell me to enter again. As you can see, I put 2001. I didn't enter the correct range. So now I'm going to enter the correct range, 2006. Enter that. It's gonna give me annually how much food is emitted in that certain country. And here's the graph for Greenland. Same thing as all the options. I can restart it or just end it, but I'm gonna restart it to get the last option out. So in the last one, I can actually enter your own personal data. The user can enter their own data to find out how much carbon dioxide that can be sequestrated. Meaning, depending on the data, let's say for instance, how much money you want to put in or whatever, you can see how much carbon dioxide you can sequestrate. So let's say enter the cost of, okay, the question says enter the cost to sequestrate carbon in dollars. So like how much money is going to take for you to sequestrate. Let's say, this would be very, what's it called? Not even, say $5. Enter the amount of carbon that needs to be sequestrated in metric tons. Let's say 20. Into the current year. Let's be honest. And let's say into the year you need to sequestrate carbon. Say by 2020. Into the market discount. Let's see. 90. The annual rate of change is the 0.15. And here it is. The cost required to sequestrate 20 metric tons of carbon from 2017 to 2020 is $60.06. So yeah, that's a bit of our code, and that's how it works.
Sequestrate carbon dioxide is complicated and requires groundbreaking research to arrive at a conclusion, and most of the time the solutions are not permanent and therefore have to be updated with time. Our project has definitely addressed the challenges, but unfortunately this work is not enough to solve the grand challenge because we use MATLAB as a tool to get an insight into the challenge and explore several data to understand the seriousness and the importance of the challenge. But considering the efficiency, accuracy of data, vastness of the program, and most importantly, efforts kept forth by the group, our project performs a pretty good job in highlighting the areas where there is need to work on sequestrating carbon dioxide.